Okay, I just wanted to go over a little bit for 917 and hopefully help you out a little. 917, we start talking about special products. So they talk about things like these perfect square trinomials. It's going to load here. So basically, a perfect square trinomial is what happens whenever I have a binomial and I square it. So here you can see I've got my binomial squared, which is the same thing as x plus 3 times x plus 3. Then I would double distribute or FOIL to get x squared plus 6x plus 9. You can also use the box method, and that would be considered my perfect square trinomial. Remember, a trinomial is a polynomial that has three terms. Let's just scroll down here. As you go through this, it talks you through how to go backwards. So how to get from the trinomial back to the binomial squared. So you'll want to read over that, but that's the basic gist of it. You just need to understand that a perfect square trinomial is when I take a binomial and I square it. Now we also have the special factoring differences of a square. Let's see if that's going to load for us. This is a little bit different because this is when I have x squared minus another squared. So notice that 4 is a perfect square. What two numbers multiplied together give me 4? 2 and 2. So I can break it down to x minus 2 times x plus 2. And that's how it'll be every single time I have a difference of squares. So, just scrolling down here, a squared minus b squared, that's going to be a plus b times a minus b. X squared minus 16, well, 16, the square root of that, or what squared gives me 16? 4. So x squared minus 16 breaks down to x minus 4, x plus 4. Sorry about that, that's the class bell. But that's the basic gist of it. So every time that I have something that is a difference of perfect squares, I can use this pattern to factor. This one is different because it's got a coefficient in front of the x, but it's still a perfect square, right? 2 times 2 is 4. So I'll just have the 2 added with my x. And that's basically what this assignment 17 is looking at.